Alright, today we're going to talk about how bones develop and grow. We talked about bones being living tissues. They continue to grow even into old age. So, at the beginning, bones form by replacing connective tissues in the fetus. Fetus inside of the uterus, a lot of the bones are still a lot of cartilage. The bones have not ossified, they're not hard yet, which makes being born a much easier process. So some bone will form in sheet-like layers of connective tissue, and those are called intramembranous bones. Those are going to be the sheet-like ones. While others replace the cartilage, and that's called endochondral bones. Chondro deals with cartilage, so basically it's replacing the cartilage in those bones. So intramembranous, sheet-like, they're broad, flat bones, and pretty much your skull. So if you look at, if I take the skull, when the skull is formed, it's basically formed in like sheets. Other than the soft spot in the baby's head is basically where your bones have not fused together yet. So in your skull, basically bone is formed in sheet-like layers and makes a very flat surface. Osteoblasts. Osteo means bones. Blast meant to make or build. So build bones. These are cells that are going to make bone. Osteoblasts are going to deposit bony matrix, or the substance that makes up your bones, around themselves in all direction, and it usually starts as spongy bone. So osteoblasts begin the process of building bones in intramembranous bones. So here I can see, here's a picture of a fetus, and I can see how it's like thinner in areas, so it's laying down in sheets. Where endochondral bones, if I look at this bone is not complete yet, and most of your endochondral bones are going to be longer bones. So your arms, your legs. You can see here too, the femur is not fully developed yet. So this way, when the baby is born, if the head was bony, it would probably crush the skull when it was born. Because it is cartilage and there's a little room for movement, it makes it much easier. So, still intramembranous. Once the bony matrix is surrounding the osteoblasts, they are called osteocytes, bone cells. So once these osteoblasts actually have some material around them, they become a bone cell. And then cells are going to build that tissue, membranous tissue, and they're going to lie outside the developing bone and start to form periosteum, the outside lining. Osteoblasts on the inside form a layer of compact bone over the spongy bone, and that process is going to continue, and that complete formation of bone is called ossification. So ossification is when your bones are no longer cartilage, they are hard, they are solid, they are completely bone and completely formed. Endochondral bones, most bones fall into this category. Like I said, all of your long bones will. They first develop as cartilage, shaped like the bone that they're going to be. So your arm bone is going to be long and skinny. Your leg bone is going to be long and skinny. And what happens is that cartilage is simply replaced by bone as it forms. Cartilage is broken down first in the diaphysis, which remember is the shaft of the bone. And then it's going to be replaced with bone while the periosteum develops on the outside. Can you come back later, Michael? I'm in the middle of, give me 10 minutes. Disintegrating cartilage, so like we said, it's completely replaced. Disintegrating cartilage is invaded by blood vessels, and then osteoblasts that form that spongy bone are at the primary ossification center in the diaphysis. This is a lot of information to process. You're going to need to read through this more than once. So, hyaline cartilage. Cartilage is being replaced by bone. When it's being replaced, that periosteum, the outside lining, is going to form on the outside of the bone. And that cartilage that was on the inside is being replaced by blood vessels, spongy bone, and that primary means first. So typically the diaphysis, the shaft, is the first place that the bone ossifies or gets hard. Osteoblasts then from the periosteum are going to continue to build bone. So they're going to make compact bone around that starting site, so where it had started. And then secondary ossification is going to occur at the epiphyseus at the ends. So primary, it starts in the middle, bone is formed. So if I have a humerus bone, when they're being, and that's why the bones are shorter in a fetus, because the primary ossification center, it starts in the middle. Secondary is at the ends where it's going to form last. So secondary ossification appears later in the epiphyseus. A band of hyaline cartilage, the epiphyseal plate, which is growth plates, are going to remain between the two ossification centers. So that growth plate basically separates my primary ossification from my secondary ossification. And layers of cartilage are going to go through mitosis, build new cells, and eventually that epiphyseal plate will fill in as you continue and quit growing. New word, osteoclast. Break down bones. So an osteoclast is going to break down bones. So they're going to break down any calcified matrix, replace it with new cells, new osteoblasts that are going to build more. So that this process continues over and over again. Osteoclasts get rid of old bone, and then osteoblasts are going to build new bone. A long bone continues to lengthen while the cartilaginous cells of the epiphyseal plate are active. Once that plate fills in or ossifies, once your growth plate is closed, that's what the doctor will tell you. Once your growth plate is closed, that bone has stopped growing. So if you have an x-ray of your arm and they are looking at the ends, if that growth plate is still open, which means it's not ossified, they can still see it, you're probably still going to grow. If it's closed and ossified, then no more growth will take place. The medullary cavity forms in the diaphysis, that's that center cavity part, due to the activity of osteoclasts. So first, basically you build kind of like almost a solid bone, and then osteoclasts are basically going to form that middle cavity in the middle. And that's where your yellow marrow and blood vessels and things like that will be. As your bones grow longer, they're also going to increase in thickness, and that's due to ossification under the periosteum. So while growth plates are responsible for bones growing in length. Thickness basically comes from just more bone growing underneath the periosteum. It just simply has more cells, more tissue that form that. So here I can kind of see a picture. I've got cartilage. It's starting to get a little bit harder and calcify. I'm starting to get my periosteum on the outside. Primary ossification center, diaphysis, it starts in the middle. I'll start to have blood vessels form. Here's my medullary cavity that's starting to form. Secondary ossification, I'm starting to have the bones harden or build on the outside. Here's my growth plate, my epiphyseal plate. So here's my primary ossification. Here's my secondaries that are left on the outside. And by the time you're completely done growing, these plates have completely hardened. They're not cartilage anymore. They appear filled in on an x-ray, and you have cartilage on the outsides of the bone, and the rest has ossified. This cartilage is what protects your bones from rubbing together. Homeostasis. So constantly osteoclasts tear down the bone, get rid of the old stuff. Osteoblasts are going to build new bone. Throughout the lifespan, resorption of the old cells, deposition of the new cells, with an average of 3 to 5% of bone calcium exchanged each year. So it's not like today I have a new bone. It is a continuous process of tearing down and rebuilding. The remodeling process is controlled by hormones, very much deals with calcium levels inside of your body. Physical exercise, we just talked about this the other day with our blood drive lady. Physical exercises pulls on the bone, it stresses the bone, it makes them hard and dense. That's a good thing. Physical exercise is good for your bones. Diet Coke is not good for your bones. It's going to do the opposite. It's going to weaken your bones. As you get older, your bones tend to weaken and osteoporosis becomes more common. Other things besides age and exercise that affect your bones: nutrition. Calcium, obviously very important for bones. You've heard that, I'm sure, forever. Vitamin D from sunlight or a vitamin itself is going to help with absorbing calcium. Hormonal secretions. Growth hormone is going to obviously increase growth of bones. And I actually know a young man who and they're not, it's not dwarfism, they're not dwarfs, their family is just very short. And the youngest one, actually the youngest two, took growth hormone, and they got very excited when they reached like 5 foot tall. So growth hormone is going to stimulate division at the epiphyseal plate, so your bones will get longer. Sex hormones, they are going to actually cause you to stop growing. So when usually during puberty, you kind of have a growth spurt, but then once those sex hormones are being produced, those growth plates start to ossify, and that's pretty much when you quit growing. And that is where I'll stop. That was a little bit lengthy for today.